So welcome to video lecture series on design and analysis of algorithms. In today's lecture, let us discuss about the fundamentals of algorithmic problem solving. So if you want to solve any kind of problem, be it finding an element in the given array or sorting the element in ascending or descending order, you want to design an algorithm that is more effective in accomplishing the task that you wish to achieve. So in order to do so, there are various steps that you need to take care of, which is discussed in the fundamentals of problem solving. So let us see the flow chart. So this is the flow chart which is designed for problem solving technique. So initially, you have to understand the problem. Next, you have to design on computational means. Next, you have to design an algorithm, and for which you have to prove the correctness. Then you have to analyze the algorithm based on time and space complexity, and once everything is fine, you can code the algorithm. So let us so if you see this flow chart, you can see once the design and algorithm phase is proven to be failure, you can either move on to deciding on computational means once again. So which, if the algorithm design is not correct, it means that the computational means which you have chosen or the algorithm design technique which you have chosen is not correct. Similarly, if the algorithm correctness is not proved, again you have to decide on algorithm design technique, or you have to recheck the way in which the algorithm is designed. So when analyzing the algorithm based on time and space complexity, the same problem may occur. So in that phase also, you will move back to deciding on computational means and designing an algorithm phase. So this is the flow in which this problem solving technique works. So let us discuss about one by one in detail. So initially, first step is understanding the problem solving. So this is a first step in algorithm design. It is very essential to understand the problem statement through the description of the problem. So on once only the problem statement is understood clearly, uh, it is able to design an algorithm effectively. So in the meanwhile, when you are understanding the problem statement, if you have any queries, you should clarify the doubts then and there. So while doing so, you have to identify the type of problem and type of inputs that will be given to the problem as well. So these are the detailed steps which should be discussed in understanding the problem. You can consider it as the empathy part. So next is uh, decision making. So here, which is the second step. So once you have understood the problem, you will move on to the decision making phase, where you have to decide on the computational means. By means of computational means, it is nothing but you have to ascertain the capability of the device that you are using. So you have to ascertain the capability of your computing device. Once it is done, you have to choose between the type of problem solving technique, whether it is exact or approximate means. So once you have decided that as well, next you have to decide on the type of algorithm design technique you are going to use. So this will be your second stage in fundamentals of problem solving. And third stage comes the ways in which algorithm can be designed. So we have three ways in which algorithm can be designed. The first one is the natural language. Uh, this is a step-by-step procedure. Initially, we will write like step one, steps two, step three, and so on. So first option is natural language, and second one is pseudocode. Pseudocode can be considered as the improvised version of algorithm. So this is combination of natural language as well as the high-end programming language. And third one is the flowchart. Flowchart is the pictorial representation of pseudocode or the algorithm. So there are three means in which you can design an algorithm. So based on the problem and based on your convenience, you can choose any of these three. It is not essential you have to choose all the three. So this will be your third step. And in the fourth step, you have to prove that the algorithm you have designed is correct. So in the third step, based on the three methods, we will design an algorithm. And once the algorithm is designed, you have to check it whether it is working correctly or not. So for that, we will give some input. It should be some legitimate input to the algorithm. And if the algorithm is able to produce the result you are expecting in finite amount of time, it means that the algorithm is correct. If it is not able to produce the required result, it means the algorithm is not correct. So you have to move back to the second stage or to the third stage. So the second stage is deciding on computational means or deciding on exact and approximate design technique and deciding the algorithm design techniques. So third one will be the designing of algorithm. So you have to move back to these either of these two steps and you have to redesign the algorithm. Again, you have to check the correctness of the algorithm by giving some legitimate input. So this will be your fourth step in fundamentals of algorithmic problem solving. And the fifth step is once the algorithm is proven to be correct, that is if it is able to produce a required result in finite amount of time, you have to analyze the effectiveness of the algorithm. So the algorithm effectiveness can be measured based on time and space complexity. So by means of time complexity, the amount of time the algorithm takes to accomplish a task, and by means of space complexity, it means the amount of memory space which is required to execute. So we have various means on deciding time complexity and space complexity of the algorithm, and if it is within the limit, uh, it can be said that the algorithm is efficient. And more precisely, uh, the algorithm has to be simple and it has to be general. So by means of general, what we are going to tell us, it should not be designed for specific range of inputs. For example, the algorithm should not be designed that could only receive integer values, or that could only receive float values. So it should be general. So these are the various ways which is used factors which is used to analyze the effectiveness of the algorithm. This will be a fifth step. And once everything is perfect, and the last step is coding the algorithm. So using any of the programming language like C or C++ or Python, you will implement the algorithm. So, and you will generate the optimized code. So which means your problem solving is completed. So these are the various steps in algorithmic problem solving. Hope the session is useful. Thank you.